All right, everyone now. Saman, we are still writing the exam? Writing? No, you'll miss it what I'm going to explain. I know, but you will miss it what I'm saying. And you don't require any concept from the last class. It's a totally new topic. So guys, today we are doing electrolysis. Everyone, give the headline. So what do you know about electrolysis? One cathode, one anode, one electrolyte. Cations go to cathode, anions go to anode. Electrolysis complete. That's it. Right? Now, so electrolysis we all know. Everyone knows about electrolysis. But what we have to learn today is how to write the product at electrolysis. How to write the product at electrolysis. Product I mean what will be deposited at cathode, what will be deposited at anode, you know, based on different conditions. So it's very necessary that we must know how to write product of electrolysis. Okay. So give the headline. What we are learning right now is how to write the product of electrolysis. How to write the product of electrolysis. Okay. And once you understand this, online students, can you all hear me?
Yes, sir.
And is the board visibility is clear?
Yes, sir.
Okay, good. So understand, once you learn how to write the product at electrolysis, you will be able to understand Faraday's law of electrolysis very easily. So there are two laws that I have to learn. Okay, Faraday's first law and Faraday's second law. All right. Next. So we have to follow certain rules. We have to stick to some rules before we learn about how to write the product at. So rule says, the first rule, write the write the anode reaction first. What does the rule says? Write the Then you write cathode and then you write overall. Anode, cathode, overall. Just alphabetical. A first, C, then O. Anode, cathode, overall. That's it. Okay. So the order is, you will write like this: anode, then cathode, and then overall. So in overall, what do? We do balance the electrons, right? We do balance, equalize the electron with the suitable multiplier. Equalize the electrons with suitable multiplier. If needed. So use the suitable multiplier when if needed. So this is the first rule. Second rule is, so remember, at the number which electron gets cancelled, that is the n value. You know this, right? At point when the electron got cancelled, that is the n value. That is how we find n. Second rule says, after you are done with anode reaction, it says consider platinum electrode unless mentioned or given. So what I'm trying to tell, if the electrode is not discussed in the question, you will by default you will assume it as platinum. And remember, why are we using platinum electrode by default? Because platinum electrode is inert. Inert means it doesn't interfere with the reaction. It just, in simple words, what I'm trying to tell, that platinum minds its own business. All right, it doesn't interferes. Okay. Now third is consider concentrated solution of the electrolyte of the consider concentrated solution of the electrolyte unless mentioned, unless it says it's molten, unless it says it's dilute. If molten, dilute, these things are not given, what will you consider by default? You will consider it by default concentrated. Okay. So guys, these three things you have to keep in mind. Simple. All right. So if it says molten, then things are different. If it says dilute, things are different. But if nothing is mentioned, you will by default assume the electrolyte is concentrated. Okay. Okay. Clear with everyone online? Yep. Yep. Yes. Gold is not preferred here. The reason with the issue with the gold is, okay, gold is, very first of all, very, very expensive. I mean, platinum is also expensive, but gold is way too much expensive. Plus, gold can take up a lot of impurities very easily, okay, as compared to platinum. Okay, so impurity is a problem. And if you have to take something else, we prefer graphite. Yes. In place of platinum, you can also assume, yeah, you can also assume graphite. Platinum is very common, but otherwise, you can also assume graphite. Graphite is the allotropic form of carbon. And graphite, it's a very good conductor of, good kya, best conductor of electricity. So it is very ideal for electrode. Okay. Next, okay. Now, factors on which, after you are done with the rules, write it down. Factors on which product of electrolysis depends. Next, you have to learn what are the factors on which product of electrolysis is going to depend. So, all of you write it down. Factors on which product of electrolysis will depend. First is nature of electrolyte, like it's more ionic or covalent or what, right? Like, let's say, is it NaCl or MgBr2 or AlCl3? I hope it's clear. Okay, one question out of the box. I mean, it's not completely out of the box. Tell me, see, in this class, few people are very regular in the JE class I'm taking, right? Tell me, out of these three ionic compounds, who has the highest covalent nature? Apply Fazan's rule and quickly tell me the answer. Yes, Amanvi. Huh? AlCl3 is the most covalent out of the three. Why? Huh? Mg doesn't even have 18 electrons. How pseudo noble gas configuration will come up? Ha, Kavish? NaCl. Why NaCl? Why NaCl? Tanish. It's not NaCl. You people recently learned, no? AlCl3. Why? Fazan's rule. That's what I'm asking. Guys, just now we did the, huh? See, so bigger charge of cation, bigger polarization. So that is why AlCl3 is the answer. It will have the most covalent nature. All right. So this is more covalent. Al3 plus. So remember, charge of cation is directly proportional to covalent nature. Anyways, do not write this part which I have bracketed. This was a discussion. Okay, separate discussion. Just write this line, that is more than enough. Okay, you really don't need to write this in the bracket. So remember, Al3 plus AlCl3 will have more covalent nature. Next, second, medium of electrolyte. Second is, so guys, what is the medium of electrolyte? Whether it is molten or whether it is aqueous. Molten or, see, aqueous or molten, it matters a lot, especially for writing the product of electrolysis, it matters a lot. Third, third is concentration of electrolyte. Is it constant? Is it dilute or? Remember, by default we are considering constant. And fourth, what matters a lot is nature of electrode. Nature of, fourth is nature of electrode, whether it is active or inert. So inert electrode, you people already know it's graphite and graphite or platinum. See, inert electrodes do not interfere or do not participate in any of the reaction in electrolysis. But if active electrodes are there, what they do? They won't allow usual reaction to take place. They will only oxidize and they will only, exactly. If inert electrodes are there, they will not allow other reactions. They will only reduce and they will only oxidize. That's right. Is it clear? So write it down. How will you identify the active electrodes? So they participate in reaction. They only do, they will only take part in oxidation and reduction both. So example is copper, zinc, iron, silver. So if you come across, this is very commonly given, okay? Silver, zinc, and yeah, silver is not an inert electrode, it's a active electrode. Okay, silver is a active electrode. So that's it. Now we will learn about finally how to write the product at electrolysis. Is everyone's done with this? Copy this. Guys, this part is not needed here. I just asked from the different context according to Fazan's rule. All right. Now, is it done, everyone? Anish. So, guys, let's learn that. So, we'll see first case, case one. So, in the first case, what are we considering? We are considering molten NaCl. What are we considering? Molten. So, if it's molten, will it have water? Will be there or not? It won't be water, right? What do you mean by molten? Tell me. You know what? Last year, I asked 12th grade people what is molten. They were not able to tell. And I was thinking at that point of time how they will do in the exam. Luckily, they all did well in chemistry. But yes, now tell me what is molten. I want to know the answer. Solid in? Yeah. Yes, molten means it's melted, right? Correct? Yeah, this batch is way better. At least you people know what is molten. Your seniors, though, they were not knowing what is molten. Now, so molten NaCl, guys. So what will happen? How they will dissociate? Na plus and now, which reaction do we write first? Who will go to anode? Na plus or Cl minus? Tell me. Who will go to anode? What did I told you about anode? Pow. Positive anode, oxidation. So if it is positive, who will get attracted? Huh? So anions go to anode, cations go to simple. How many electron? Anode is oxidation, right? So loss of electron. So which gas is produced at anode? Chlorine gas will be liberated at anode. And what will happen at cathode? Cathode mein what will happen? Addition of to which metal is deposited. Exactly. And now what is the overall reaction? And what is the overall reaction? Electron, electron got cancelled. So what is the N value here? 2. Yes. N value is 2. So what is the overall? It gives Na plus plus Cl2. It's just Na and Cl2. Plus it's not equal. It should be 2Na. Huh. Now it's fine. Is everyone's clear? So which electrode is here? It's not given. Which electrode is present at anode? Yes. For anode it will be platinum. Now do one thing. Rutvik, show me how do you write the cell representation of this? How do you write the cell notation for this? First, salt bridge. Then left, what do I write? Anode, very good. So it will be Cl minus and then Cl2 and then platinum. Very good. And after that, on the right side, cathode. So what do I write for cathode? Na plus. Very good. And after that, Na. Good. And you have to no, that's it. Platinum. Why platinum will come for Na? Na is solid, right? All right. Is everyone's done? Shashank, come here. Sit in the front. Come, come. Be quick. You know why I called you friend? Because soon I'm going to ask you a question, and if you are not able to answer it, right, it will be a problem for you. Now, probability is high that you will be able to answer now, since you are in the front. Okay, so I saved you. Okay, is everyone done? Okay. Has everyone copied this? Okay, write down next case. So second case, what we have, this time you take aqueous NaCl. Case 2. Case 1 was molten NaCl, right? What are we taking now? Aqueous NaCl. Basically, we took a brine solution. Now tell me, is it dilute or concentrated? It's not mentioned. It's concentrated, simple. It's not mentioned, right? If it's not mentioned, what do we consider by default? You will take concentrated. And which electrode will you take here? Platinum. Electrode will be? I hope it's clear. So now tell me what will be the dissociation? How NaCl will dissociate? Na plus and how will H2O dissociates? H plus and brilliant. Now, how many anode is there? One. Why you said two? Since when anode became two? So anode is one. And who gets discharged at anode? Anions. How many anions are there? One. Who said one? Two. Anions are two, but anode is only one. How many cations are there? But cathode is one. So it's like there are two winners, but prize is only one. So how will you decide who will get a discharge? Very good, Samanvi. So in that case, we use, so understand, in this case, we use preferential discharge. We'll check the, so who will guide us for preferential discharge? Electrochemical series. So in order to decide preferential discharge, use electrochemical. Now tell me, which reaction do I write first? Anode. So tell me, above ones are better anodes or below ones? Hmm? Who are better anodes, above or below? I told A for anode, A for above. A for anode, A for A for anode, A for above. So who is above in the electrochemical series? Cl minus or OH minus? Cl minus. So Cl minus, 2 Cl minus will lose 2 electrons to form Cl2. I hope that is clear to everyone. Guys, got it, no? And guys, say one more thing, pay attention, it's very important. I usually like this reaction, okay? But how NCRT has written that 1 Cl minus lose 1 electron, it forms half Cl2. So there is no difference between these two. So NCRT version is this and my version is this. Both are correct. Okay. Now, chalo, NID is sorted, right? Now, use preferential discharge. So cathode below ones are better cathodes. So compare hydrogen and sodium. Who is below? Who is below? That's right. So hydrogen will get discharged. So 2H plus gains electron. So it forms. So what's produced at anode? Chlorine gas. What's produced at cathode? And write the overall. So what is the N value here? What is the N value? At what number electron got cancelled? 2. So N value is 2. So 2Cl minus 2H plus. That's the overall we are writing. Gives Cl2 plus H2. That's the overall, right? Now pay attention here. When it was molten, so H2 was not in the picture. But when it was aqueous, it came into a picture and things changed, right? And what remained in the solution? Yes, so you write it down. NaOH remained in the electrolyte solution. So if NaOH is remained in the solution, what will happen to the pH? Will it increase or decrease? So resultant pH, NaOH is a base, so pH increases. And what is the use? What is the significance of this reaction? This reaction, this process is, this electrolysis method is used for preparation of, this is used for preparation of, say it, caustic soda. Who is caustic soda? Na, which is called caustic soda. And you know this cell is called Kastner-Kellner cell. Kastner-Kellner cell. What do we call it? Cell. You have studied this in grade 10 in acid bases and salts chapter preparation of NaOH. Brine solution, right? Electrolysis. Brine solution and electrolysis. And this is called chloralkali process. And why it's called chloralkali process? Because chlorine gas is formed, alkali is formed. I hope you have some memories of 10th. Anyways, is it done? Take a note of this. Online, does everyone understood this? Sophia, you understood this reaction? Anya, Ashmita, Ridhima, Neha, Rohan, DJ.
Yes. Yes, sir.
Okay.
Yes, sir.
See, I'll try to show you the picture also how Kashner-Kellner cell looks like. I mean, there only this electrolysis happens. In this cell only, this electrolysis takes place. Kashner-Kellner cell. I hope it will be able to read my handwriting correctly. Let's see. Oh, almost there. It took my Kellner properly. Kastner, no. Ask me anything. Now it took it properly. Yes, this is the Kastner-Kellner cell. This is the Kastner-Kellner cell. This is how it looks like. In this only you prepare. Hey, no, no, no. This is the modified form. That is the modified one. Guys, this is the one. This is the one. This is the one. This is the one. That is the modified one. This is the, okay, chloralkali process. Is it clear? Now you collect NaOH as much as you want. You have prepared it, caustic soda. This is how we prepare actually. Is it done? So this anode and cathode can be of, here you have taken platinum or it can be a graphite, okay? Is it done? Okay. So are you all done? We'll go to the next part. So how many cases we have discussed? Huh? Now let's discuss third one. And by the time I will reach fourth, you people will ask me, sir, how many are there? Who said five? You have watched the video. Then how do you know? Oh, it's correct. There are five. Okay. So guys, No, I remember I've shared the someone has exam and I have shared the last year's oh, okay. That's why I thought you have watched. Okay, third case, guys. You see, third case is aqueous. So third case is aqueous NaCl. Now you'll ask me, sir, how it is different? It is different because it's dilute. It's mentioned. It's dilute. It's not concentrated. Okay. Now something will happen. Let's find out what something is. So how NaCl will dissociate? Na plus N. Now how H2O will dissociate? H plus N. Now preferential discharge rule, electrochemical series will die here. It will not work. Ask me why. Why? Because due to large amount of water, the water will outrun everything else. Due to large volume, due to large volume of H2O, H plus and OH minus will get discharged. Will get, will get, please note it down. Your preferential rule will not work here because it's already aqueous. On top of that, it's dilute. So water is in large amount, okay? Is it clear? Now, so guys, so what's gonna happen then in that case? In that case, so write the reaction at anode. Guys, now in anode, who is getting discharged? Huh? Chlorine. Just now I told these two are getting discharged. So OH minus. Now it's very crucial that you need to know what happens when any guess anyone knows what happens when OH get discharged. What is produced if OH and hydroxyl ions are discharged? What it is produced? Who knows? If Cl minus is discharged, Cl2 is formed. If H plus is discharged, H2 is formed. If OH minus is discharged, what will form? H2O is the incomplete answer. I'll tell you. Pay attention to the details carefully. You have to mug up in simple words. So OH ion, 4 OH ion will lose 4 electron to form 4 OH. Now tell me, can I write this 4 OH like this? 2H plus 2H. Can it be written like this? Yes or no? Now 2 moles of, now you will produce 2H plus 2H. Okay. Now what is produced? Understand. So it will form 2H2O. What it will form? Now, if from 2OH and 2OH, if I have taken 2H2O, what is left? Tell me. Yes. So the leftover O will produce O2. So the final anode reaction will be, the final reaction will be 4OH minus loses 4 electron to form 2H2O plus. So this is the final anode reaction. Did you get it? I have explained in detail, but understand this. When OH ion discharge, it forms H2 and O2 like this. You have to remember this. Online, did you not get this? And then cathode is easy. Cathode is easy. 4H plus, 4 electron, 2H2. And now what is the N value? What is the N value? N value is 4. Very good. Because at 4 it got cancelled. there is going to be a many instances. Guys, listen carefully. There is going to be a many instances, especially in batteries, where you would know these details. So better you get adjusted with this. How OH ion gets discharged. I hope it's clear. Online, did you all get this? How OH ion gets discharged? Kindly confirm. So just from changing from molten to aqueous, concentrated, something else came. And when concentrated was made, dilute, something else happened, right? Now, case number four. Case number four. Write it down. Is everyone's done? Should we go to the case four? Huh? Is it done, everyone? Ridhima, do you have any doubts so far?
No, sir.
Okay. Ruhan, Neha, Ashmita.
No,
No,
sir.
sir.
ठीक है. And Anya, DJ, Sophia,
Yes, sir.
Tanish, Kalyan, Tarun, Rutvik, and Samanvi, Sakshita. Ruhan, present. Neha is there. Ridhima, Ashmita, Anya,
Yes,
Aryan.
sir.
No, no, I was just taking attendance. So, yeah, Shashank, come back. Okay. So, guys, all of you write it down. We will talk about the fourth case. Fourth case is NaCl, okay, aqueous NaCl you take. Aqueous NaCl with mercury. Aqueous NaCl with mercury, Hg. Now tell me, so how NaCl dissociates? Na plus plus. And how will H2O will dissociate? H plus and now. So see now because of mercury, how things changes. So guys understand here. So this time it's dilute, concentrated, doesn't mention. So what do we consider? We'll consider concentrated. So who will get discharged now? We will use the electrochemical series. So Cl minus is preferred over and H plus will be preferred over? No. Na plus will get preference. So write it down. Na plus is preferred over H plus. Write the reason. Hg increases the solubility of Na and forms NaHg alloy that is called as amalgam. This is the modified form of Kastner-Kellner cell. Okay. Yeah. So because of mercury, see, mercury did not affected the anode reaction. Mercury did not affected the anode reaction. Mercury affected the cathode reaction where it increased the solubility of Na. Hence, Na was more preferred over H plus. So how do you write the final reaction? So at anode, what do you write? At cathode, what do you write? At overall, you write. So guys, you will be writing here it is as expected. In cathode you have take a note of this. So guys, it finally produces see once the sodium is formed, sodium mercury forms amalgam. Mercury with any metal, it is called as amalgam. What do we call it? Yes, amalgam. I hope it's clear online. And we move to case number 5. So this is the final cathode. Okay, electron will get cancelled. That's fine. Clear no? See, make sure after you show that sodium is deposited, sodium formed with mercury amalgam. See, is it clear? NaHg amalgam. Now let me show you this wala cell also. Guys, now look at this amalgam. NaHg amalgam. I hope it's clear. So mercury is the cathode. Do you see that? Samanvi, check this diagram. This is your Kastner-Kellner cell, the amalgam one. See who's got deposited. It doesn't hamper chlorine. Anode reaction it has not influenced. It happened as per electrochemical series. It only influenced the sodium. It was supposed to be hydrogen, but because mercury increases the solubility of sodium, hence sodium got discharged over hydrogen. I hope it's clear. Tanish, you understood, right? So overall I have shown, no? This is anode, this is cathode, just write overall, that's it. Cut the electrons. Online, did you all understood this? So remember, so here the mercury which was used, that is cathode. Mention that. Mercury was Kastner-Kellner cell. This reaction indicates which cell? Kastner-Kellner cell. Yes. And the second reaction which you have studied, you write it down chloralkali process because it's a simple one, right? Chloralkali process, second reaction. Second one you say chloralkali and the fourth one is Kastner-Kellner. Any guesses what is the last case? The fifth case. Any guesses anyone has? We will see when there is a active electrode. Yes. Fifth case is about active electrode. So all of you write down case number 5. The last one. Aqueous NaCl with active electrode. So aqueous NaCl with active electrode Ag. Ag is one of the. So how will NaCl dissociates? Na plus. I think I wrote this for like so many times. How will H2O because it's aqueous? Now tell me what will get discharged at anode? So Na plus or H anode, right? Anions. Cl or OH? Who will get discharged? Online, everyone tell me. Samanvi, who will get discharged? Will it be Cl or OH? Huh? Guys, it will be none. I told you, no. Active electrodes forms oxidation reduction. So this nothing will get discharged. Nobody will get discharged. Silver will only react at anode and cathode. So it will be Ag forms Ag plus one electron. And after that, at cathode, this Ag plus will gain one electron to go back to Ag. That's it. All other reaction stops. I told you, no. All reaction stops. Only active electrode participates in cathode and anode, right? So what's the overall? What's the n value here? N value is 1. Yes. N value is. Remember, so guys, this brine solution will remain in the electrolyte. This will remain in the solution. Yes. So Electrodes, active electrodes participates in both the reaction. This reaction is used in electrorefining. Remember in 10th grade you have studied anode mud. All the anode migrates to cathode and only left is impurity and as anode mud. So used in which process? Electro electrorefining. That's right. Okay. So guys, we are done with electrolysis. All of you copy this. Now we have to start Faraday's law, numericals. Everyone copy this.
So can you show case for 1 second?
Yeah, I'll show you in a minute once everyone's done with this.
Okay.
Okay, so need to know. So guys, I hope now if they ask you to write the product at electrolysis in any of these five cases, you will not do a mistake, right? Was it hard? It's easy, right? Kavish, sort of. Last two are difficult. Active electrode is the easiest of all. OH one, you did not understood. I told no, OH will form H2 and O2. That's it. That much you have to remember. Is everyone done with this fifth one? So I can show the fourth one, okay? So how many people remember electrochemistry studied in grade 10th? Extraction of elements. You remember? Electro. Huh? So there was a process, electrorefining, where the impure anode and pure cathode, all metals migrate from anode to cathode, only anode mud impurity was left. It is that reaction. It is used in electrorefining. Is it done? So what happened over time? Anode started losing weight and cathode started gaining weight. See, you will take a pure silver as cathode and you will take a impure silver as, and when you start this reaction, over time, all the silver in the impure part will go to cathode. Only impurity will be left as anode mud. Yes. All right, guys. Fourth one, right? Someone wanted to see the fourth one, guys. Please copy this. So, guys, I have also noticed one more thing I will tell you. What I have noticed is in schools, mainly when the teachers are covering this electrochemistry, they skip this part, okay? Electrochemistry, electrolysis. Please understand it's very important, okay? Oh, they skipped in your school, okay? So, 3 days, they did not even talk about electrolysis. They directly went to Faraday's law, right? Quite understood. How? This is so sad. Let me show you something. Why it says no data? Library books, CBSE. Ah, now it came. Yeah, what do you say? Okay, this is a better question. I thought you were saying who will study the NCRT book. Guys, look at this topic. Electrolytic cell and electrolysis. So here they have given Faraday's law first, and then they have what they have discussed. There is a separate section in NCRT clearly talks about product of electrolysis. You learnt it already. But remember, question do comes from here because there is a section here. It's not here one line the teacher told it will not come. Okay, 70 out of 70 doesn't come like this. Okay, so remember this. Anyways, now you people have done it, and I have covered both NCRT part as well as the JE part, okay, and NEET part. So you don't have to worry because NCRT discussed only few types. We have done all of these, okay. I hope it's clear. Okay. So note down the page number where you have studied this product of electrolysis. Page number 52, NCRT reference. Online, is everyone's clear? NCRT page 52. Now give the headline. Everyone give the headline Faraday's law of electrolysis. Yeah. What happened? Does anyone has any doubt? Then stop the discussion. I need one diagram for this Faraday's law of electrolysis. Images. This is, I don't want this. Yes, this is a good one. Online, please tell me if you are able to see this diagram properly or not. Or you need a bigger one. Is this much fine? Everyone confirm? So guys, please look at this. There is a current I. Hey, pay attention. There is a current I flows at time t. Current I, 1 second. Current I flows at time Time what? Current I flows at time t. Plus you can see you have cathode, anode, anions, cations, right? I hope it's clear. So if current I flows at time t, so what is the relationship with the charge? You know, Q is the charge. Q is the charge. So tell me, if Q is the charge and current I is flows at time t, so how do you establish a relationship between Q, I and T? Q is equal to, very good. Q is equal to I into T. That's correct. And remember, uh, the T will be in seconds. T will be in the, note it down. You must draw the diagram. You must draw this. And guys, wait. Also remember this. What is Faraday's first law? So guys, remember, according to Faraday's first law, what does Faraday's first law says? First law says that whatever the amount of current you will pass at time t, you know, the mass deposited or liberated at cathode or anode will be equal. You know, it will not equal, I mean, it will be proportional. So in simple words, I can say Faraday's law said that mass deposited or liberated will be equal to, you know, what do I say? M is directly proportional to Q. M is directly proportional to the charge. M is directly proportional to the charge. So to remove the proportionality, what do I bring? M is the mass. I hope you all know, right? So to bring the, so what will bring? A constant. Constant is Z. Z and Q is I into. So can I say M is equal to ZIT? Huh? And you know what is Z? Z is called as electrochemical equivalence. Which constant is this? Which constant it is this? Electrochemical equivalence. Which constant is this? Now understand, Z also has a formula. Z is E by F. Z is, pay attention everyone, Z is E by F is where E is equal to, E also has a formula. E is the equivalent mass. What is this E? E is the equivalent mass. And F is the 1 mole of charge. How much is 1 mole of charge? Faraday's constant. What is it? What is the value? That is how much? Faraday's constant is 96,500 coulomb. Remember, Faraday's constant represent 1 mole of charge. 1 mole of charge. Now, E is equivalent mass. What is the E formula? Molar mass by N factor, number of electrons transferred in the reaction. You have studied this, right? Molar mass by N. Now you know. So did you all understood Faraday's first law? It says that the amount of mass deposited at electrode or the gases evolve liberated at electrode is going to be equivalent to the charge you will pass. So that's why M directly proportional to the charge, and charge is IT. Charge is, and remove the proportionality, we will use the constant electrochemical equivalence. And what is the formula of Z? E by F. E is the equivalent mass. How do you calculate equivalent mass? Whatever the molar mass is there, divide by N factor. N is the number of electrons transferred. N you know, right? We have studied this in Nernst equation, right? Online, is everyone's clear? First law? Kindly confirm.
Yes, sir.
Now, in exam, they will expect you to write the statement also. So the statement says the mass of substance deposited or mass of gas liberated at a particular electrode is directly proportional to amount of charge. Guys, all of you read the statement. This statement they'll ask you in the exam. It says mass of substance deposited or mass of gas liberated at any electrode, right, is going to be directly proportional to amount of what? Charge passing through electrolyte. That's why M is directly proportional to Q. Q is the charge. Online, did you all understood this now? And based on this, they'll ask you questions. So remember, a very, very important thing I'm telling. If you see two electrolyte in the question, it means it's Faraday's second law question. If you see only one electrolyte, it means it's a first law question. Okay. Because in your senior batch, when I taught both the laws and I started giving question, they told, sir, can you help me? Can you please tell how do we know it is a first law, second law? I was like, salute to you all. Okay. So that's why I'm telling you all. Remember this, that if one electrolyte is there, it talks about first law, then you'll use these formulas. If it is a two electrolyte, then second law. Second law we'll discuss in the tomorrow's class. Okay. Yeah. Tomorrow we are studying all, conductivity, conductance, resistance, all these things. And tomorrow we are also completing second law. And after that, only and only Coloros law will be left. And Coloros law will be left. And we also have to see special cases of Nernst equation with delta G and Kc. Okay, equilibrium constant and Gibbs free energy constant. Yeah. So, Saman, we were not done. Don't fold the notebook. Huh? Okay. So, has everyone copied? Now, let's do numerical. Okay. And if Sashank does this numerical, the class will get over. Okay. So, let's do this. Has everyone copied? And golden chance because first numerical is always easy, which I give. Okay. Ruhan, any doubt, difficulty in understanding first law? Neha, Ridhima, all of you kindly confirm.
No,
Anya,
sir.
Sophia, Aryan. Okay. So Sashank, understand, whatever charge you'll put, that much equivalent amount of mass will get deposited at electron. That's it. First law can be summed up as, guys, first law can be summed up as whatever amount of food I'll give him, that big he'll grow, right? Understood, Shashank? Same thing first law is, right? Got it, everyone? You're studying physics, right? I is the current. I is the, here I wrote small. How does it make a difference? You are not liking this? You write capital. It doesn't matter. Do you feel better like after this? It doesn't matter. All right. Time in seconds. T is time in seconds. Now, Sashank, are you ready for the question? And everyone. So, guys, please get ready. Question. Obviously, it's a board exam question, so calculations are going to be annoying, irritating. Be ready for that. Find the no calculator. You are not getting a calculator in the board exam. No calci. You start doing it in college, in engineering. Their calculators are permitted without covers in the exam. When 5 amps current, guys, solve this question now. Shashank, if you do this, okay, class is over. Everyone do this. You're done? Okay. Online, everyone do this. You don't know how N is 2. In copper sulfate, once again, in what is the formula of, so it is 2. Ah. Huh? No, it says 63.5 means you will use 63.5. No, no approximation, guys. Please do it, everyone. Online students, once you finish, tell me the answer, then only you can leave the class. So, Shashank, 1 hour has 60 minutes and 60 minutes has 1200 seconds. Right? Shashank? Now, another question. If 60 minute has 1200 second, then what is your age? Very nice. I will tell this to your mom that according to you, 1 hour has 1200 seconds. See, very nice. Say thank you, I saved you. Otherwise, one more question you will solve. Now do it. So find the amount. It means the mass. M is equal to ZIT. Yes, that's correct. 5.9 something kya? 5.9, one more value I need. Standard. 5.8. No, 5.9 something. Solve it. Don't. Yes, that's correct, Kavish. Very good. 5.92 is the right answer. So guys, Z is equal to E by F, right? Z is equal to E by F, and E will be how much? 63.5 by 2 by. So can I write it like this? 63.5 by 2 into 1 by 96,500. So this whole thing is for Z. So I can write it as 63.5 by 2 into I into, guys, see this, right? So solve this, what you'll get 5.92, and those who are not writing units get 0. 5.92 gram, that is the amount which will get deposited. This is the answer. Online, huh? Very nice. You heard him, you wrote 5.92. You did not calculate. Yes. It's taking long, so what? You will leave it. You will not, you don't want to calculate. You will live in the exam. In exam, I'll do. अभी नहीं हो रहा तो exam में क्या होगा? कुछ नहीं होगा. Do it now. These are traits of a very bad student. He will get marks nicely. He'll score. What about you? You'll suffer. You will see each and everyone's faces, right? Okay. Ashmita, Ridhima, guys, are you all done? Sophia?
Yes, sir.
Yes,
Alright,
sir.
guys. So we conclude the class today. We'll continue tomorrow. Bye, everyone.
Thank you.